Section 1.2, number 82. We're given three equations. We're supposed to identify the relationship between the equations and do it so that the slope appears visually correct, right? So I have a nice square grid, and I'm going to use it to build my equations A. We're given that y is equal to 2/3 x, right? Which means that we don't have any extra bits here, which means that this thing, when x is 0, y is 0, which means we go through the origin. The slope of 2/3 means that when x is 3, y is 2, which means we go up 2 every time we go over 3. So the line through that looks something like this, right? Instead of a slope of 2/3. B, are given y is equal to negative 3/2 x. Okay, again, there's no extra little bit here. There's no offset, which means when x is 0, y is 0, so we go through the origin here as well. We have a negative slope, which means we're going down, right? So when x goes over 2, y goes down 3. So something like this. Again, modulo my ability to do it right. Now, one of the things we notice is that this 2/3 and this minus 3/2, they're the negative reciprocals of each other, right? Negative 3/2 is equal to negative of 1 over 2/3, okay? Which means that this B is the reciprocal of A, right? That means that it's flipped over. That means these things meet at 90 degrees. So B is perpendicular to A. Okay. Now C is y is equal to 2/3 x plus 2. All right, so this time we do have an offset. So when x is 0, y is 2, and then we have a slope of 2/3, which means that we, again, every time we go over 3, we go up 2. And so this thing, it'll look like that. Hi, Milo. My cat is trying to prevent me from drawing straight lines here. All right, okay. So C and A have the same slope. So that means C is parallel to A. Thank you, Milo. And it has the opposite slope. It has the negative reciprocal of the slope of B, which means that C is perpendicular to B, right? So if C is parallel to A and B is perpendicular to A, B has to be perpendicular to C. So this also meets at a right angle. So that, I believe, is all the things that we are asked to verify, and it is. So there we're done.